So Chris Bizon is one of my fellow directors at RENCI. He's Director of Analytics and Data Science. He spends a lot of time on machine learning things, visual analytics, a lot of semantic web words, and then has spent a lot of time with knowledge graphs in the last couple of years. I think that's the new hotness again, more. So before that, he spent time thinking about genomic analysis and clinical genomics. And so he's now in charge of a whole team of people doing smart stuff. So come on up. Chris Bizon. Thank you.
All right, good morning, everybody. I don't know if you've heard, but knowledge graphs are not the new hotness anymore. LLMs took over. But that's okay. And to some degree, that is the point of this talk, which is that the old hotness is still the new hotness. And specifically, I'm going to talk a little bit about what is the role of data management in the age of AI. And I think you can quibble about whether this is the age of AI if you want to, but I think it's probably at least good for a magazine cover. Okay, so this is a text that I dug out the other day that I sent to my family. They didn't think it was very funny, but I like it. I don't know if you can read it very well on those screens, so I'll read it out to you. It says, I thought of this because, of course, we're at the Bulls Stadium. So, we come here and watch a lot of ball games, and I sometimes watch them on TV. And I happen to be watching this Bulls game one afternoon. And essentially, the pitcher stands up, is going to throw the ball. Before he throws it, a ball is called. And there is a pitch clock in the game now. And I thought, he took too long. But I was listening to the announcer because it was on TV, and they said it was because the pitcher didn't make eye contact with the batter. And I thought, I don't know what that is, right? I mean, I watch a fair number of ball games, but I hadn't heard of that. So I went to Google, and I typed in, pitcher has to make eye contact with the batter. And this is what the Google AI told me. And I think it starts off pretty well. It gets a little confused at the end. All right, so it says, in Major League Baseball and minor league baseball, the new pitch clock rules emphasize the importance of eye contact between the pitcher and the batter. This is all true. The rule is designed to reduce game time and prevent stalling. Also true. Making eye contact signals that the pitcher is ready to throw and the batter is expected to be in the box and attentive. All right, also far so good. Then it goes on. Refusing to make eye contact can result in a desist, and if after 5 such instances, the pitcher can challenge the hitter to a duel. I mean, there are people who think baseball is a little boring. I don't. I'm not one of them. Google AI seems to be, and they are looking for ways to maybe improve the game. I don't know. Actually, what is happening here, I think, if you kind of do a bit more Googling and sort of avoid the AI part and look around, you can kind of trace this back to a New York Times article from a couple of years ago where a guy was doing a sort of kind of an old man yells at clouds article about the new changes to the game and saying he didn't like them. He thought that these were kind of babyish rules. And he was jokingly saying this, right? So there's a little bit in there. You can see pitcher or hitter refuses to make eye contact and gets a warning for it after 5 disses. So he made up this stat called a diss. Then the pitcher may challenge the hitter to a duel. So Google AI grabbed this, right? It found this one weird little snippet out there and served it to me as a fact. I mean, one of the oldest rules of computer science, right, is garbage in, garbage out. And this is an interesting case, in my opinion, because it's not garbage. I mean, well, it may be a bad opinion, but it's not technically garbage data, right? What it is a joke. And the problem is the tool that went to get this information didn't really know what it was getting, It just sees text, and it grabs it, and it says, here we go, and it does something with it. So The issue here is less about well, I mean, there is a certain amount in which it's the LLM is dumb, and there is a certain amount of is this garbage, but really it's about the proper use of the data. And it's about understanding what the purpose of that data is and how should we bring it into a system in a useful way, right? Okay, all right, so let's say that you see that and you're like, well, I want a chatbot anyway, right? How are you going to make sure that your chatbot, say, responds to user requests in a way that doesn't have somebody standing up in front of a crowd making a joke about how dumb your AI is? Then what you need to do is essentially control the data that that LLM is going to look at and use in its responses. The sort of standard way to do this is with what's called retrieval augmented generation, where you take a bunch of information that you control. You know its provenance, you know its structure, you know where it came from, right? You know all the things, and you say, this is what I want you to look at. You need a way to index into that so that based on whatever the user asks, you can find the relevant information, right? Because you may have a fairly large corpus, more than that LLM is going to look at query time. So you need a query time to be able to go, okay, I found the one document or the one piece of information that I want you to use to respond to this. You give that back, and the LLM hopefully does something somewhat reasonable. But it's up to you, right? If you are the person building this RAG, that's your job, right? Your job is to understand the data, and it's to choose the data that's going to go in there and properly curate it and properly make sense out of it. One form of data that is used in some of these systems is what we call a knowledge graph. This is an example of a knowledge graph. It is probably not a new concept to most people, but I'll just walk through it for a second. A knowledge graph, in some senses, is just a database. It's just a database with a somewhat different structure. And the structure is you've got things or concepts, entities, right? These are blobs or circles on a page, and relationships between them. These are the lines between the blobs. So your blob, your thing, might represent a gene, or it might represent a disease, or it might represent a company, or a ball player, or whatever. And then the edge represents a relationship. You know, pitcher didn't look at batter, or something like that. This is an example of one that is about sort of biomedical things, which is where we do a lot of our work. And the entities in here are things like a gene, DDHD1, or a process like a lipid metabolic process. And when you string all these kind of entities and relationships together, we call that a knowledge graph. Okay, so why do I tell you that at that point? Well, a knowledge graph is one of the sort of backing tools that you can use to structure the information for one of these RAG systems. And so this is an example of some work being done at RENCI, where we have a bot that is there to answer questions about data sets. And specifically, what we want to know is what are the entities that are described in these data sets. So these are, say, big cohorts, right? The NIH pays a lot of money to build giant cohorts. And these cohorts have a group of people, and so when they bring someone in, right, for their visit into the cohort, they do a whole bunch of things. They take their blood pressure, they do their height, their weight, they have all of the particular measurements that they're interested in, and then they take all those things and they basically write a bunch of text about it and stick it in a kind of a gross Excel spreadsheet and shove it somewhere that no one ever looks at it again. And the goal of this bot is to first take that data and extract decent metadata from it. So we have to look at those column headers or that data dictionary, convert it into useful entities, like what do we really mean here by blood pressure, and is this blood pressure the same as that blood pressure? And then put that into a graph that relates this set of variables to the data sets of interest and to all the other things that we know about blood pressure. And that way, when somebody comes in and says, I'm interested in a particular gene, say, we can go into our knowledge graph and say, oh, well, if you're interested in that gene, we know that gene influences blood pressure. I can tell you about the data sets that may have something to do with that gene. But again, it's all based on being able to control the information and understand the metadata around the data sets. Of course, there is more to AI than LLMs, unfortunately. And so this is a question that I asked ChatGPT a few months ago. I said, okay, analyze every possible combination of FDA-approved drugs and known diseases to suggest the top 10 most likely drug repurposing opportunities. So what is drug repurposing? Drug repurposing is you've got a disease and you could develop a novel drug for it, right? That's what drug development companies are doing all the time. But you could take a drug that we already have for another disease and apply it to that disease. This is a lot cheaper, right? Because you don't have to prove that this drug is safe for people, it's already been in people. You just have to find that, oh, it's got this other effect that we didn't know about. So it's a very efficient way, well, to treat diseases if you can pull it off. And so ChatGPT kind of went off and it thought for 44 seconds, and it came back with this thing, and I'll just read you this one part. In practice, analyzing every possible combination of FDA-approved drugs versus all known diseases is an enormous computational task. I think it got a little snippy with the air quotes there. But I work at a computer science institute, so this kind of thing is catnip, right? We like this. So we have this other project that we work on called EveryCure. Well, it's called Matrix. EveryCure is a foundation that supports it. And this is exactly what we're doing. We are building machine learning models that try to compute a score for every known disease, of which there are 20,000-ish, according to some systems, by every known approved drug, of which there are 3,000-ish. So you say, disease 1, drug 1, what's your score? 0.2. All right, let's move on to drug 2 on disease 1. You got a 0.3 and so on. And then you do that and you fill in the entire matrix. And then you go to specifically the ones with the highest scores. If you don't care about which drug you're treating or you're using, which most companies do, right? But we're not a company, so we don't care. And if you don't care about which disease you're treating, which a disease, someone with a disease would, but don't, just want to help somebody, right? This gives you essentially what is the lowest hanging fruit for treating somebody. And that's the idea. This is, again, all based on these knowledge graphs. And I won't belabor this, but you can take knowledge graphs and turn them into a bunch of numbers, and then use your normal machine learning machinery to eat the numbers and tell you more numbers. But those numbers hopefully mean a score that says something about how well that drug might treat that disease. Okay, so what? That's nice, but what does it have to do with any of this? This is a related project where we are doing similar but different things called the NCATS Biomedical Data Translator. And in this case, I have asked it to tell me, can you tell me drugs that might treat a particular disease? And in this case, it was immune-mediated necrotizing myopathy. And it's come up with a list of possible drugs for treating that thing. And what we found is it's extremely important to be able to track the provenance of these answers. So we have some reasoning engines behind this, and they come up with these drugs. But when we show it to a user, if they can't trace it back to the actual evidence that went into that statement, they mostly wander away. They do not care, because we can give them a whole bunch of stuff, but they can also just go to the literature, right? They can also just think for themselves. They don't really necessarily need us to come up with a hypothesis, but if we do, we sure better be able to support it. And we better be able to support it by going all the way back to source data, meaning papers or databases, and say, I got this piece of information from this row. And Otherwise, they simply don't trust it. What's more, we need that data to be of high quality. We don't want to be in the garbage in, garbage out world. We don't want to mistake some joke for a real piece of information that then we make some crummy prediction, right? And so we have a tool here where we consume structured data. Usually these are databases. Sometimes it's papers. And we run it through our processing tool to create our knowledge graph. And one important aspect of this, really for us, is that we create and expose all of the metadata around the sources, the entities, the processing. We know all the versions of all of the tools. We know all of the versions of the data sets. And we can really trace back exactly what happened and where any piece of information came from. This is part of the point, is there is actually a fairly nasty little secret hiding here, which is we're going out to all these data sets and we're consuming them. And we're making all of our nice metadata and we're making it into machine readable formats and we're allowing everyone to see it. The vast majority of these data sets out in the world that we're consuming don't really do that very well. You know, they simply do not provide metadata about their repositories in a way that is in any way standard, okay? Certainly not machine readable. And often it's just a bunch of statements on a web page, not all on the same web page. This one, you know, if you want this piece of information is here, you know, here's where you can find the license, but over there, thank you, is, you know, the description of the data. A lot of the data is not actually described, it's just an Excel spreadsheet and maybe you got to figure it out for yourself or it's described in some text document somewhere. So one nice thing is that there are actually some pretty good standards coming out for this kind of thing. One that I happen to like is this thing called Croissant, which I had nothing to do with, but I think is pretty cool. And it provides metadata around the data set, you know, who made it, where does it come from, how do you get it, what's its license, and so on. And then information about the particular resources that make up that data set, and then information about the structure of the data within those resources. So you can really get quite granular with it. And one of the things that we're working on is making these for people, right? So there's a whole bunch of these repositories that we use, and it would be really nice if they had these metadata files. They don't, so we're trying to make them. But we're trying to use AI to help us make them. Because what you gotta do is you gotta go crawl around on these websites and dig into their files. Well, there are tools for this. So you can have a crawler, a web crawler, that just goes and pulls a bunch of data. You can feed that to an LLM and you can say, hey, go look in all this junk and find me the license for this thing, right? And it does an okay job. It doesn't do a great job. The croissant may have come out a bit wonky. So there is a case where we now pass it back through a human, say, clean this up, and now we've got a nice, you know, metadata file we can pass back to this source and say, you know, please, please put this on your website so we can use it from now on. So I'll stop there, and I'll just say that, you know, I think that this case highlights maybe a bit of a flip of the question. Instead of, you know, what is the role of data management in the world of AI? You know, what is the role of AI in the world of data management? Are there places that, you know, you all are able to make use of things that are happening out there, right, to improve your workflows or your work? Okay, thank you.
All right, thanks, Chris. Do we have any questions for Chris? Yes.
Anyway, great talk, thank you. So it's very interesting, I'm really interested in the basic stuff that I do, but so the croissant, you said the data sets, these data sets that you're looking at don't have any metadata or good data, metadata, and croissant is the standard for applying metadata, but if they don't have metadata, are you creating it or discovering it?
Yeah, it's sort of a discovery situation. Thank you for that question. So if I look at one of these sources, these might be, you know, a knowledge base or something, but they've typically got a web page. And that web page, it's got a set of, almost all of them have a set of tabs kind of thing about this, get the data, downloads. They're all different, right? But they all have that structure with this set of tabs. And almost all of them will list something about a license somewhere. But it may be just an annotation on the bottom of the page. This is a Creative Commons whatever. It may be a page that is called license that contains some text about what their license is. It might be a page called something else, like legal, right? That says that this is their license. It's in there somewhere usually. It's a matter of, though, because it's in this completely non-standard way where everyone's done it differently, discovering it and getting it into the right place, into some structured thing that we can say, okay, now I know where it is the game. So it's more about discovery from a big mess than it is about creating it. Sure.
All right. Any other questions?
Okay.
All right.
Thank
So
you.
we got one here.
So hi, this is Terrell. What's the hardest thing that we're going to be able to actually solve in the next couple of years?
With AI?
Well, just with all of this connectivity and new thinking. I mean, there's low-hanging fruit. And
Right.
There's more interesting fruit, but there's also stuff that's 50 years away. Right?
Absolutely. I mean, so that's a live wire question that people fight about on the internet, and my personal feeling is I'm a little bit of a skeptic on the reasoning front. I think it's extremely unlikely that we're going to get AGI in a couple of weeks. There are people going around saying we're going to cure all human diseases. I don't think that's going to happen.
More than 2 years.
Yeah, more than 2 years. But that said, I think it's kind of silly to ignore the abilities that we do have. What we have is a set of tools that are extremely good at understanding language in a way that 10 years ago, none of us would have said is doable, right? The ability to take these, take language and convert it into abstract reasoning tokens is a pretty wild thing, right? So I think we're going to see a lot of cases where we figure out better ways to make interfaces with this, to extract knowledge. I think the one real important thing that we can do now, better than we could ever do, is extract structured data from unstructured data. That seems to me to be one of our main use cases here. So,
All right.
all right, thank you.
Oh, we have a question in Slack. All right, Justin.
How easy has it been to feed back your discovered metadata back to the institutions? What are the sources of friction?
Yeah, we're still very early in that, and so most of our conversations have been with friendly folks. So I don't know yet. We do have some concern, right? There is a certain amount of skepticism about wanting to accept anything that's got a little bit of the stink of AI on it. So we're going to find the answer to that question out pretty soon, but I don't have a good answer yet.